Okay, hello again. Today's going to be a relatively short lesson, at least short for me, because I tend to be long-winded. What we're going to look at is a procedure called simplifying radicals. This is a tool that we're going to be using as we explore quadratics a little bit more. This is read as square root 9 or radical 9. This symbol is called the radical symbol. There is an implied and invisible number on this radical. Right here, there is an implied 2, which means the second root. And what this is asking is, what number times itself 2 times is 9? And so, one thing I can do, and you probably know the answer to this, I hope you do, is I can take this and rewrite it as the second root or the square root of 3 squared. Now, so what number times itself is 3 squared? Well, the obvious answer is 3. 3 times 3 is 3 squared. But that's not the only answer, because not only is 3 squared equal to 9, but negative 3 squared is equal to 9 also. So when we take the square root of a number, we end up with 2 solutions. Now, often we'll want to refer to just one of those, just a positive root, just a negative root. For right now, though, if I write the square root of 9, we're going to get 2 solutions, plus or minus 3. And there are ways we'll talk about where if I just want to look at the positive root, this is how we'll denote it, and if I just want to look at the negative root, etc. Okay? So, looking at square root 16, again, you probably know the answer, but I'm going to do something here. I'm going to again rewrite it as that is the square root of 4 squared. What number times itself is 4 squared? Well, it's 4, but we now know it's plus or minus 4. Cool, cool. That leads us to something that's kind of important. If I've got the square root of anything squared, I get that thing that's underneath. And it's going to be plus or minus. So the square root of anything squared is itself. That is a helpful tool when we're looking at something like the square root of 72. Now, I can't take the square root of 72. There is no number times itself as 72. It is an irrational number. In fact, if you can't take the square root of an integer and get an integer, it is an irrational number. It's a non-terminating, non-repeating decimal. But I could approximate that on my calculator. Let's see. That would probably be about, let's see, 8 squared is 64, 9 squared is 81, so somewhere between 8 and 9. But there's a way we can write a more exact answer, and that's by simplifying this radical. A couple ways we could do this. First way is to rewrite this number in its prime factorization. 72 is 8 times 9, and then 8 is 2 times 2 times 2, and 9 is 3 times 3. Now, what we're going to do is look for pairs of numbers. I've got a pair of 2's, I've got a pair of 3's. Why are we going to do that? Because now I can rewrite this as the square root of 2 squared times 2 times 3 squared. Now I can use that property, the square root of anything squared is itself. I can break these up into the square root of each of these individually. The square root of 2 squared is 2, no longer underneath the radical. Square root of 3 squared is 3, no longer underneath the radical. That remaining 2, I haven't taken the square root of it, so it stays under the radical. So we end up with 2 times 3 is 6 times the square root of 2. That is called the simplified radical. Now, you look at that and you may think, well, I'd rather just, use my calculator and get that to be, 8.4 or whatever it is. Well, that's not an exact answer. This is an exact answer. And in a lot of cases, especially for you advanced, you brainiacs, we're going to be looking at cases as we move in pre-calc and calculus where we need the exact solution. So that is a simplified exact solution. Now, with these radicals, we're going to be looking at expressions that are going to end up looking something like this. And we need to simplify this. Now, what I want to do, I've got a binomial expression. I've got -6 plus or minus two different operations there, the square root of 9 over 6. I want to first simplify this radical. This one's easy because the square root of 9 is 3. And notice that in this expression, that plus or minus gives me plus 3 minus 3. It gives me both roots. That's a very intentional thing. And I still have this all over 6. Now, a couple routes we could go here. One way is to first combine the tops. Since I don't have radicals, I've got actually two numbers up here. -6 plus 3 divided by 6, and -6 minus 3 divided by 6. Now, working up top, combining these, I get -6 plus 3 is -3 over 6, and that simplifies to -1/2. Up here, I've got -6 minus 3, that's -9 divided by 6, and that simplifies to -3 halves. Cool. So that's one way, if we can, just take the top, take that -6, that first term, plus that number over the denominator, -6 minus that number over the denominator. Another way we can do this, which sometimes is handy, is to go ahead and split this up. If I've got a binomial over a monomial, I can split that up as -6 over 6 plus or minus 3 over 6. And I end up with -1 plus or minus 1/2. So I've got -1 plus 1/2, which would be -1/2. And -1 minus 1/2, which is -3/2. And I can write those two solutions as just this one comma this one. All right. So let's make this a little bit ugly. Here we've got an expression very similar, except now I've got the square root of 40. That's something I can't take the square root. That's an irrational number. So what I want to do, I want to write out the two solutions generated here, this plus that over 6 and this minus that over 6, in simplified form. So the first thing I'm going to do is simplify that radical. Well, let's see. I showed you how to break it down in primes, look for pairs. That's one way. There's also the intuitive way. I know that 40 is 4 times 10. And I know the square root of 4 is 2. So I can go that route. Now 10 breaks up into 2 times 5, and they can't simplify any further than it is. No pairs there. So now what I want to do is write this. I have two solutions here, two answers to this. And I want to express that. The way I'm going to do this is to break this up like we did it with the last one, the second technique, I'm going to break this up by putting -4/6 plus or minus 2 radical 10/6. And now just simplify these. I get -2/3. Now, I can't divide it inside the radical. That's on the order of an exponent. I do exponents before I do division or multiply. But what I can do is work outside. 2/6 simplifies to 1/3. So I get 1 radical 10/3. All right. Ugly looking guy. Now, another way that you could do this is, and get an equivalent expression, is to look at this top expression here and think, what is the greatest common factor between these two terms? Now, I'm just looking at the 2 here, not the 10. He stays in the radical. That's sacred. Well, between 4 and 2, I can factor a 2 out. And now I can take this monomial 2 and simplify it with this monomial 6. 2/6 is 1/3. And so I end up with -2 plus or minus, I forgot my minus there, radical 10/3. And what we get is the same thing we had before, except it's written as a binomial over a monomial. Equivalent expressions. Okay, I kind of like the first way better. Now, you take a minute, pause the video. I'll run out, get a pizza real quick. Well, I probably don't have time for that. Get something to drink. You pause the video and do that. All right, now we're back. What did you do? Well, hopefully you simplified that radical first. And let's see, I'll do this a slow way. 50 is 5 times 10, or 5 times 5 times 2. And that's all over 4. Those are a pair of ugly 5s. Then, well, let's see, I got a pair there. Square root of 5 squared is 5. And now, I'm going to split them up. Go over here. To 10/4 plus or minus 5 radical 2/4. And I can simplify that to be 5/2 plus or minus 5 radical 2/4. All right. Did you get it? Well, what I would like for you to do, go back, review this. Not really hard stuff. I think you've seen a lot of this before. We will come back tomorrow and in class, we'll do some practicing with this and then see how we're going to apply this in something that you're probably familiar with called the quadratic formula. So I will see you tomorrow.